All right, so again, we are dealing with all different types of percent problems that we might see in real life. So, taxes, real life problem that we're all going to eventually have to deal with if you're not already. Excuse me. So, a taxpayer claims the new sports team caused his school taxes to increase by 2%. Write an equation. Going to do this on your homework. To show the relationship between the school taxes before and after a 2% increase. So again, we want an equation. So whatever, whatever your taxes are based on, we can plug that in. So even if your total is different than mine, we can figure out how much our total cost tax is going to increase. So I'm not going to worry about the values here, but we're increasing 2%. We've done a problem like this before. Let's say our taxes stay the same from one year to the next. If they stay the same, I'm paying 100% of what I paid last year, right? Not any more, not any less. Except we're paying an increase of additional 2%. So be careful in this case. Remember, we always talk about, don't think of it as the increase or decrease, but actually what percent we're paying. We're actually paying 102% of our taxes because we're paying 100% of what we paid before plus the increase of 2%. So we need to make this into a decimal, right? And we have 1.02, okay? Actually, let's go back here. We're going to pay 102% of our tax before, right? We're paying 102% of what we were paying before. So 102 times what were we paying before? Use B to represent the dollar amount of school tax before the 2% increase. Okay. And use T to represent the dollar amount after the 2% increase. All right, so the tax we're paying now is going to equal 1.02 times the tax we paid before. Okay. So this is our increase. Now we can use that, or that represents our increase. We can use that equation to fill in this table. All right, so let's say, well, let's just start here with 1,000, okay? These are B here, so I'm just plugging these values in right here. So for 1,000, my T is going to equal 1.02 times 1,000. And that's 1,020. Do the same thing for 2,000. Take 2,000 and plug it in for B, so I get 1.02 times, get a little sloppy here, times 2,000. And we get 2,040. Because our T here is dependent on our B values. All right, so now we get to pick some values. So let's say I pick 0, right? 0 is a good one to pick. If I plug 0 in here and I go 1.02 times 0, well, I get 0, right? And it makes sense. If I didn't pay any taxes before, if you increase nothing by 2%, you're still paying nothing, okay? Now, notice that these, we're multiplying, okay? Notice we're multiplying. So we're multiplying here. What if I want to go the other way? What if I have the T? Well, basically, I'll show you two ways of thinking about this. Remember, using our equation here, if we know T, we could plug these values in here. And I could say 3,060 equals 1.02 times B. And since I'm solving for B and it's multiplying, I'll do the inverse and I'll divide. So I'm going to do this division problem right here. 3,000. Which makes sense, right? Because it kind of looks like this is proportional. Looks like we're going up 20 each time. Now, we could also think of it as if we're going from T to B as dividing, right? And that's actually what we did right here. So we actually could take 6,120 and divide it by 1.02. And that would be 6,000. Okay, so we can't just say this is 4,000. We'd have to do division. Okay? So is this relationship proportional? Well, I hope we're all saying yes. Okay? Explain. we have the same constant, right? There is a constant of 1.02, and we'd say it goes through 0, 0. We didn't really graph it, but we see 0, 0 on there. Okay, or we could say, yeah, somehow, if you have paid 0 taxes, you're going to have a $0 increase. Okay. All right. So again, what's the constant of proportionality? The constant of proportionality, I just said it right here. 1.02. Okay. What does it mean? Well, it means we'll say we're paying 102% of last year's taxes. I'll say of taxes before. Okay, we're paying 102%. 100% plus an additional 2%. All right, last one. If the taxpayer's school taxes rose from $4,000 to $4,220, was there a 2% increase? This is a percent increase. Now remember, how do we do percent increases? We take the amount of change and we divide it by the original amount. So how much did this change? Well, 4,020 minus 4,000. And where did we start out? Well, we started out at 4,000, so we divide it. So this ends up being 20 divided by 4,000. And we get 0.005. Now, knowing what we do about changing things to percents, I move it 2 places over, and I basically get 0.5%. Okay, was there a 2% increase? No. Okay, there was a 0.5% increase, 0.5% increase. Okay. All right, so taxes obviously are something you're gonna have to deal with in real life. And as I told you before, percents, this is a real life thing. We do it whether we're getting paid a commission, whether we're leaving a tip, whether we're paying taxes, whether we're getting a discount on something. So really try to use common sense and what you know in real life to help you with these problems.